In this video, we'll cover stratified sampling. Stratified sampling is a useful way to get more precise estimates if you know something about how the response variable varies over the survey region. It can also be used to sample some parts of the survey region more intensively than others. In the previous video, I introduced a simple example which we're using to get an idea of how different sampling methods work. Just to recap, there are 51 plots, and each plot has got a certain number of animals in it. We don't know how many animals are in each plot, but what we're trying to do is to estimate the total number of animals across all 51 plots. The catch is, we're not going to visit all 51 plots, we can only visit 6 of them. In the previous video, we saw how we can use design-based inference based on a simple random sample to get an estimate of total animal abundance. Here we assumed that we knew nothing at all about the survey area. We just chose 6 sites at random and then used the inclusion probabilities and the values at those 6 sites to get an overall estimate of abundance. Now in reality, there's a clear trend for there to be more animals to the right of the area than to the left. And in this video, we'll pretend that we know something about this trend. Not the exact numbers, but just that there is a trend. How might we use this information? Well, one way would be to divide up the whole survey region into a small number of subregions where we expect the response to be similar. So here, for example, we could take the survey region and divide it up into 3 zones. One, the green area, where we expect low counts, the blue area, where we expect medium counts, and the purple area, where we expect high counts. This is the basic idea behind stratified sampling. Because we're using simple random sampling in each stratum, we can use the same calculations as I went through in the previous video. So for example, in the green zone, the estimated number of animals is 15 divided by the inclusion probability. Now here, in the green zone, there are 17 sites, 51 divided by 3, and we're choosing 2 of them. So each site has an inclusion probability of 2 over 17. To that, we add the count for the second site divided by its inclusion probability, and we come up with an estimate of 374. What that means is that we expect there to be 374 animals in the 17 sites in the green zone. We can do the same calculations in the blue and purple strata. At that stage, what we have are the estimated number of animals in each of the 3 zones. We can add these together to come up with an overall estimate of how many animals there are over all 51 sites. Here, that sum is 2,414. That's pretty close to the true value of 2,429. Because we're using simple random sampling within each stratum, if we redid the survey, we'd land up with different sites and therefore different estimates. Here I've shown another possible survey with different sites. Here the total estimate is 2,346. Here's a third possible random sample. Different sites again, and here the estimate is again 2,346. The thing to recognize here is, because we're sampling within a particular stratum, we expect these numbers to be fairly similar to one another. And we expect there to be quite significant differences between different strata. Roughly speaking, this means that overestimates in one stratum can be compensated for by underestimates in another stratum, and overall we'd expect this to reduce variability. Here I've drawn 5,000 stratified random samples. For each sample, I've worked out the estimate of total animal abundance, and the blue histogram shows the distribution of those estimates. For comparison, the grey histogram plots the distribution of 5,000 simple random samples without stratification. You can see that there's much less variance in the stratified random sampling estimates. We'd expect this pattern if we've chosen our strata well. Well means that responses within a stratum should be similar, and responses should be different between different strata. A nice feature of stratified random sampling is that it doesn't matter too much if you don't choose your strata well. If responses are not that similar within strata, you just won't get the expected gains and variance that are on this figure. Instead, things will look more like the simple random sampling case. So to summarize, the key idea of stratified sampling is to divide the survey region up into smaller regions called strata. It works well if responses within strata are more similar than responses in different strata. If that's the case, you can expect more precise estimates. In our example, we selected 2 sites from each stratum, and therefore used the same survey effort in each stratum. This doesn't have to be the case. It's possible to sample some strata more intensively than others, and this can be very useful for snow leopard surveys. For example, it's possible to put more effort into high density areas than into low density areas.